Mrs. Arndt here. This is your Math 3, Week 4, Lesson 1, and it is all about trig graph discovery. So what does this talking about, this trig graph discovery? Well, we have done a little bit of this before we left for spring break even. And so just one reminder about what trig graphs look like normally. So the y equals sine of theta, where theta is an angle of rotation. Thinking all the way back to that Ferris wheel problem where we started on the far right and we went up the circle and down the circle and then we made it back to that starting point. So if we're talking about sine and we're talking about the heights of that Ferris wheel, we started at a height of the center axle and then we went up to hit the peak. We came down and made it back to that halfway point. And then we went down to the very bottom of the Ferris wheel, and then we made it back to that center line on the axle. So that's the sine graph, and this is based on the unit circle because we have a radius of 1. So that's the highest we get, and -1 is the lowest we get. When it comes to the cosine graph, we didn't spend as much time with this. Cosine had to do with the direction that you were off of center, thinking horizontally. So it might almost help to flip the page sideways because this was the farthest right point on that Ferris wheel. And then as we went up the Ferris wheel, our x values moved to the left, and then they hit the -1, and then they made it back to that starting point on the far right. So that's what's happening here, thinking about the horizontal movement. So the sine graph starts right on the center line or the midline, but the cosine graph starts on the peak. So those are the two main graphs that we're working with. So when it comes to transformations of these functions, y equals a times sine, or it could be cosine, doesn't matter which function we're dealing with, of b times x and then plus d on the end. So these three parameters do different things. That a value on the front, that's the amplitude or the vertical stretch of the graph. The b parameter that's trapped inside with the x, it has to do with the number of cycles that fit in the space of 2 pi radians. Well, it has to do with frequency of how fast this thing is rotating. However, for today, b is going to be equal to 1 all the time because it's going to be based on the normal graph, because one full cycle of cosine fits in the space of 2 pi. One full cycle of sine fits in the space of 2 pi. So b will equal 1 for everything we do today and on Delta Math today. Lastly, the d parameter on the end, this is the value of the midline. It can be positive or negative, depending on where the midline is, and it's really a vertical shift. That's what that d parameter is. So when you hit Delta Math, it's going to walk you through writing equations for different graphs that you're looking at. So the three parameters, we need to identify the midline, the amplitude, and then like I said, b is equal to 1 today, no matter what. So on example 1 here, if we're looking for that midline, you can work on eyeballing it, trying to figure out where it is, or you can utilize the formula that we had in last week's lesson. So our highest point is 0, the lowest point appears to be -4, and so what's the average? 0 plus -4 divided by 2 is -2. -2 is the midline. So what does that mean for our equation? The d parameter is -2. So that's what we would fill in or put in on Delta Math. Then we would need to find the amplitude. So from that center line, how high up does this thing stretch? Well, it gets to 2 units above the midline and 2 units below the midline. So that means our a parameter is 2. And lastly, as mentioned, how many cycles fit in the space of 2 pi? 1 full cycle fits there. b is equal to 1 no matter what. So when you fill in those pieces on Delta Math, it will show you that how this would really be written is y equals 2 times cosine of x minus 2. That's how it would really be written. But again, you're filling in the blanks on Delta Math. Let's try one more example. We're going to go over the 5-minute limit. Example 2, writing the equation back here. Once again, find the midline first. So we've got a peak at 5, lowest point at -1. So if we find that average, 5 plus -1 divided by 2, that average is +2. So that's our D parameter, that +2. The center line has shifted up 2 units. From there, we need to find the amplitude. So how high up above that midline do we get? Well, we get stretched 3 units above and 3 units below. So our A parameter, our amplitude, is 3. And lastly, how many cycles fit between the space of 0 to 2 pi? 1 full cycle fits. Like we mentioned, B will always be equal to 1 today. So our final equation, y equals 3 times sine of x plus 2. That would be the transformation of this sine function. Head on over to Delta Math, practice these, do this trig graph discovery, and good luck out there.